So I've got a question here, and the situation is we've got a pulley with two weights on either side of the pulley as it goes over, held by a string. Now, one weight is 4 kilo, the other weight is 3 kilo. So as this thing starts to move, it's going to go in the direction of the heavier weight. So that's the 4 kilo one. And this heavier weight starts 3 meters from the ground. Now the thing acting against these weights is going to be the tension in the string. That's going to be caused by the weights acting against each other. So we want to calculate the acceleration of block A as it falls to the ground. So that's as it's coming this direction. So that'll be going that way. Calculate the velocity of block A on impact. So when it hits the ground, what's the speed? And distance of block B travels after block A hits the ground. So when block A hits the ground, block B will still be going up a little bit. And then the force of block A falling will no longer be acting on block B. All that will be acting on is the initial speed, and then gravity will act against it, and then it will go upwards and then back down as the string becomes taut again. So calculate the acceleration of block A as it falls. So if we want to calculate acceleration, in this case, we need force equals ma. That's mass times acceleration. That's Newton's second law of motion. As this thing is moving, it's not actually in equilibrium. And another thing we need is the gravitational constant. So in this question here, I'm going to use 9.81. It's actually 9.81 meters per second squared, which is the gravity, the acceleration of gravity. So force equals ma. Let's deal with what's going on in these forces. So at A, let's have a look at A. What's going on at A? So on this side of our pulley. So the block is going to be coming down. So the force is coming down is going to be 4 times the gravitational constant multiplied onto this block. So that's 4g. And going against it in the other direction will be the tension in the string. And that equals mass times acceleration. And the acceleration of this whole system we don't know. All we know is the gravitational constant, which is that. So ma, well in this case, it's 4 times acceleration. And then at block B, what have we got going on there? Well, it's going to be going upwards, so tension this time is going in the right direction. So it's the correct direction, so it's positive. Mass times acceleration will be 3 times A. And what's going to be working against it? Well, this time we've got 3 times the gravitational constant working in the opposite direction. So that's the force in newtons going the other way. So we've got a situation now which very often occurs in these situations. 2 equations, 2 unknowns, one is t and one is acceleration. So to solve those, it's just like a simultaneous equation where we can eliminate one of the variables and get the other. Well, these are just constants. These are values we don't know, and acceleration is a value we don't know. So here, as we've just got t with coefficient 1, we can just add them to get that to eliminate. So then we've got 4g minus 3g equals g. So I'm just going to write that there. The t's disappear. And then 4a plus 3a is 7a. So now we can get a on its own. So a equals g over 7. That's the acceleration for our block as it falls to the ground. Now, as g is 9.81, this is going to be approximately 1.4. 9.81 divided by 7 would be approximately 1.4. So if I just put approximately 1.4 meters per second squared, that's our approximation. But I'm going to use it in this form for the rest of the question. Now from that we could find the tension if we wanted. So we could do 4g minus t equals 4a. In this case our a is now g over 7. So 4g over 7. And then solve for t. And then t would equal 4g minus 4g over 7, which would give me 3 3/7 g, which would be 24g over 7. So that will be the tension in our string. So now calculate the velocity of block A on impact. So when we're trying to calculate velocity, we're going to need our SUVAT equations. So that's part one. Now let's do part two. So first of all, when you've got a SUVAT question situation, first of all, list out your variables and see what you actually have. Well, we've got acceleration, that's g/7. We want to calculate velocity, so that's definitely the variable we need. So v is what we need. U is our initial velocity. Well, as it starts, it's going to be at rest, so that's going to be 0. Distance, well, we know the distance is 3 meters, so that's a 3. Now t we don't know, but we can actually get away with not actually needing that because we've got 1, 2, 3, 4 variables and we only need to find one of them. So the SUVAT equations have always got 4 out of the 5 different variables in it. So in this situation we can use v squared equals u squared plus 2as. Okay, so now all you'll do now is just plug in our values and see what we get. So v squared equals u squared, which is 0, plus 2 times a, which is g/7, and times s. So what is s? S is 3. So I'll just change that for 3. So then v squared, we've got our v squared now. 2 times g times 3, so that's 6g/7. So therefore, v is the square root of that. So v equals square root of 6g/square root of 7. And if you want to rationalise that, to get the square root of 7, if you prefer, multiply top and bottom by root 7. So then that equals square root of 42g/7. And that be our v, that's our velocity as it hits the ground. So if I just write those results in there. So v equals root 42g/7. And our acceleration here is g/7. So that's our calculations as we're going along. Now we've got this last one, block B, how far does it travel after block A hits the ground? Now what happens there is after this block hits the ground, this block B is still going to go up a little bit. So just imagine that there is our 3 meters. Block B will still go up a little bit, but then it will come back down again as the gravity acts upon it. And when it falls back down again, the string will go tight again when it gets back to this position here. So we need to work out what the distance is that it's travelled up and then maybe double it. So let's get back to our SUVAT situation because we're looking for a particular distance. So in this case we need s. So s is our distance. So that's what we want. U is our initial velocity. So before the string before block A hits the ground, the distance of, the speed is going to be root 42g/7. So we can write that in there. We've got root 42g/7. So now it becomes the initial velocity because that's the velocity at the start of this phase of what we're trying to calculate. And then v is our velocity when it reaches the top. Well, when it reaches the top, it's not going to be travelling at any speed at all, because it's going to be going up, stop, and then come back down. So v is 0. Acceleration, well, the acceleration will be the acceleration due to gravity. Well, gravity will be going in the downward direction, so our acceleration in this case will be minus 9.81. And t, we don't know the t. We've got 4 variables here, which we know t is not of any use to us. So now we've got s, u, v, and a. Similar situation here, so we use this equation again. So then we've got v squared equals u squared plus 2as. V squared is 0. U squared is this one squared. Well, we know what that is because it was in here. We've got 6g/7. So no need to work out what that is and square it again because we've got it already. And then plus 2 times a times s. Well, a is negative, so I'm going to change my plus to a minus. Then I've got 2 times 9.81 times s. So then just need to solve for s. So then I've got, for 2 times 9.81, that'll be 19.62. So I've got, if I just bring this over here, I've got 19.62 s equals 6g over 7. And then just solving for s, I can just divide both sides by 19.62. So s equals 6g over 7 times 19.62. Then all I need to do now is to double that to find the total distance, because it's going to go up and then go down. So then times that by 2. So now coming out of this to find 2s, that will be my distance travelled up and down, which will be the total distance. So 12g times divided by 7 times 19.62. So let's work that out. 12 times 9.81 divided by 7 times 19.62. Well, we know that this is 2 times that, so that will cancel out and call that'll be a 2. And then we've got 12 over 14. So then that becomes 6 over 7. And our distance is in meters. So this is going to be 6/7 of a metre. So that would become around about 85 centimetres. That's as an approximation, 85 centimetres roughly. You can get the exact version if you like with the decimals, but its exact distance is 6/7 of a metre. So that would be what I declare as my answer. And the same here, my velocity on impact, and then my acceleration is g over 7, which we know is approximately 1.4. And that completes that question.